Scenario: a Formula One engineer is reading the following data on a monitor while a Formula One car is being driven on a racetrack. During the curve, the speed of the car is staying around 64.4 meters per second, and the tire on the road has a coefficient of kinetic friction at 1.2. During the turn, the driver will experience about 3.5 Gs of gravitational acceleration downwards on the body. The data display shows the car entering a curve. Here's the question. If the car maintains the same average velocity around a curve, at what curve radius will the car start to slide off the circular curve? Here's the answer. We first have to take a look at the centripetal force in the x direction. Here, the summation of your centripetal force is equal to the force of friction. It is what is keeping the car on the circular path. The centripetal acceleration Fc can be written as mv squared over r. Force of friction can be seen as mu mg. The mass is cancelled. Multiply by r. You get v squared is equal to mu gr. So if you take the square root, you can see that when velocity is equal to the square root of mu gr, this is the maximum speed the car can travel before it starts to fly out. But if Vr is greater than the square root of mu gr, the speed of the car goes so fast that it will fly out. That means the velocity is greater than the centripetal acceleration, which is the friction force. So knowing this, we can now approach this problem. Let's label our information. Here the V equals to 64.4, the mu equals to 1.2, and the G is actually 3.5 times 10. The reason why is because normal G, normal gravity, you can assume can be rounded up to 10. But if you notice that the driver here experienced a 3.5 Gs, so it's 3.5 times 10. So this is how much gravitational acceleration that the driver feels on his body or her body, 3.5 meters per second downwards. Now you can plug in the values into the equation here, and you should notice you could solve for r. Roughly, this is when the radius is around 99 meters. So around 99 meters here is when the driver would have to start slowing down. But notice that this here has the driver continuing at the same velocity even though the radius increase. So at this moment, after 99, at this moment right here to the right, the driver's off the track because the grip of the car, which is the force of friction, cannot keep the car on the racetrack.